Okay, welcome everybody to the Electric Education Center session number 10. We're going to talk today about the NEC 2014 major changes. First and foremost, let's determine what states are still using the 2014. As of February 2021, February of this year, besides Alabama, Louisiana, Oklahoma, and Montana, there's a block of states in the Middle Atlantic region comprised of Pennsylvania, Delaware, Maryland, and Virginia that are all 8 of those states are still using the 2014 NEC. There are 27 states now using the 2017 NEC, and 9 states have already adopted the 2020. So this one and the next 2 educational sessions are going to discuss the changes that were made in those 2 NEC cycles also. But for today, it's the 2014. The changes in every code cycle are numerous, and as you know, the changes are generally made to increase safety because there's either been a body count or somebody's been hurt on the job. And these injuries are what's being addressed. Let me give you a short explanation how these changes are generated. In the front of the NEC code book, there's a list of 19 code making panels. Some panels are assigned only 1 article, while other ones can have up to 16 articles to handle the changes that come their way. You hear people saying that the manufacturer makes all the changes, and that's just not completely true at all. There are many entities involved in making the code making changes, and many entities involved in the code making process. The makeup of each code making panel is generally this. There has to be at least 1 signatory electrical contractor, a union contractor like a NECA member or an IBEW member. There has to be at least 1 non-union electrical contractor, an independent electrical contractor on each panel. There has to be a manufacturer's rep. There has to be a nationally ranked testing laboratory like UL or Intertech, one of those companies. There has to be special experts on the subject itself on every panel. And last but not least, there has to be an IAEI electrical inspector on every panel. IAEI is the International Association of Electrical Inspectors. Their headquarters is down in Texas. You can Google IAEI and look at their memberships. And if you're not a member yet, you should join. They put out 6 excellent magazines a year. It's a great way to learn. It's also a great way to network. And then there's local chapters in all over the United States that you could join. And that's where you go and you get your training. You're sitting in a room with a bunch of other electrical contractors, electricians, engineers, people that are in the industry. The inspectors are there. And it's a great way to network, and it's a great way to learn. So look up IAEI and join today. So as you can see, there's a well-rounded group of industry experts on each panel. It's not like the manufacturer comes in and says, oh, I want tamper-resistant receptacles approved. That's not how it works. If you would ever like an official interpretation for any code-related item, you can always contact the chairperson of that code-making panel that covers that article. The one that I did ask for an official interpretation was, I had a couple guys contact me and said, Rich, this inspector is making us put hospital-grade receptacles in a dentist's office. And you have to understand these hospital-grade receptacles are real strong receptacles. They're made with strong blade holders so that the plug can't fall out of the wall on its own. And they have to be installed, if you look in Article 517 for healthcare, they have to be installed within 6-foot radius of the patient bed location. I don't know of any patient bed locations in a dentist's office. And as a matter of fact, at my dentist's office, the only thing I see plugged in is a TV or the dental hygienist radio. And that's it. I don't see any important things being plugged in. So I asked Don Talco for an official interpretation, and he said, Rich, I can give you one. Don Talco works for UL, by the way. He said, Rich, I could give you an official interpretation. He said, but the code book is quite clear on where you need these hospital-grade receptacles. So he said, I would recommend you take it from there. which we did. So if you're not happy with your AHJ, you're not happy with your electrical inspector, you can always go running to the code making panel and get a background on that. You'll be very surprised at the information you get. All right, so you could track these guys down, like I said, by contacting the organization they represent, and that's a little bit on the code making panel. So let's get into the major changes of the NEC now. Okay, first up is the NEC section 110.26E2. This follows 110.26E1, and it's a new section. And what it says is the dedicated equipment space is now applied to the outdoor installations as well as indoor. So when you install a circuit breaker panel on a wall, the space below that panel down to the floor line is all the electrician space. There should be no gas lines, no drain lines, no sewer lines, or anything like that. And then the 6 feet, the first 6 feet above the panel also belongs to the electrician. That's the electrician's territory because they have to get in and out of this circuit breaker panel with conduits or non-metallic sheath cable or MC cable or whatever they have. So that's a new section that also applies to outdoors. There's no foreign systems allowed, no non-electric piping, no duct work, no sanitary waste lines, no rain gutters, no rain vents, nothing. Nothing means nothing. Well, Rich, what do you expect me to do when the plumber runs the gas pipe and the waste lines underneath my electric panel? What do you want me to do then? Well, the answer is to think ahead and not put those gas lines and drain lines there in the first place. Or if they have to go there, you have to go somewhere else. Well, now, Rich, there's only one wall. Everything has to go on one wall. All right, that's fine. Then what you have to do, since you're the only guy that can do it, is you have to build your panel out from the wall. And then in the footprint of the panel below and the footprint of the panel above, you would have your clear working space. So that's just one of the ways that you have to handle it. Check it out with your AHJ. So let's get into the GFCI changes for 2014. The GFCI protection device, whether it's a receptacle type or a circuit breaker type, must be installed in a readily accessible location. And that means you can walk right up to the location. No ladders are needed, no crawling over or under any kind of duct work or anything like that. You should just be able to walk right up to the location. Well, Rich, the panel we have is locked. Is that considered readily accessible? And the answer is yes. It's readily accessible to the guy with the key. Whoever has the key for that locked door on the circuit breaker panel can walk right up to it. That is considered readily accessible. You need GFCI protection within 6 feet of any and all sinks in the dwelling unit. It used to say kitchen sinks, then they added wet bar sinks, then they added laundry sinks. And now the code making panel just gave up. They said, look, within 6 feet of any and all sinks in a dwelling unit, you have to have GFCI protection for the 125 volt, 15 and 20 amp receptacles. All non-dwelling unit indoor wet locations, like you would see in a car wash building, for example, that's an indoor wet location, needs GFCI protection for the receptacles. Locker rooms and associated shower facilities, like in Planet Fitness, have to have GFCI protection. Non-dwelling unit garages, all 125 volt, 15 and 20 amp receptacles. So at the car repair shop, Firestone, something like that. They have Walmart. They have to have these 125 volt, 15 and 20 amp receptacles, all GFCI protected. Dwelling unit laundry areas. Notice it's not rooms. The original word was rooms in the code, but the code making panel changes to say laundry areas. Because if you have a laundry, a washer and dryer machine in a basement, and it's wide open there, that's not a room, it's a laundry area. Okay, they require 125 volt, 15 and 20 amp receptacles, GFCI. And that dryer receptacle, that 240 volt dryer receptacle, I'm coming up on that, that will have to be GFCI protected also. All dwelling unit dishwasher outlets. It's not saying receptacles, I'm saying outlets. So the outlet covers whether it's a receptacle or direct wire. needs GFCI protection. All dwelling unit dishwashers. Well, Rich, my inspector says the dishwasher must be cord and plug connected. And that's simply not true per the NEC. So now if there's an ordinance passed in your hometown that says it's got to be that way, that's fine. But somebody's got to show you that in writing. But I'm talking about the National Electrical Code Book here now. And the code book says you're allowed to connect a dishwasher with a cord and plug. It doesn't say you have to. But whether it's direct wired or plugged in, you're going to provide GFCI protection for that dishwasher. All right, now let's move on and get to the AFCI changes, arc fault circuit interrupters. The 2014 NEC added kitchens and laundry areas to the list of areas that require AFCI protection. Well, Rich, does that include the kitchen countertop receptacles? Yes. How you handle it is up to you. Probably the best way to handle it is by using a dual purpose circuit breaker, which has both the AFCI and GFCI built into one circuit breaker. So basically now the only areas not AFCI protected are the bathrooms, garage, and unfinished basements of this dwelling unit. Rich, am I allowed to put the bathroom circuit on an AFCI breaker if I want to? Sure. Go right ahead. You could always do better than the code. Rich, can I put an AFCI breaker in the panel and GFCI receptacles on the kitchen counter? Yeah, absolutely no problem. Now let's mark off in your book, or if you're making a list, 210.17. This new section here, 210.17, says if you're going to install a receptacle or an outlet for a car charger in a garage, it has to be an individual branch circuit, something you would call a dedicated circuit out on the street. Now note there's no requirement yet to install one in the first place. But if you should install a circuit for that car charger in the garage, that there can't be any other outlets on that circuit. It has to be an individual branch circuit. 210.52G. If you take electric out from the house, for example, to a detached garage or a shed in the backyard, you will install at least one receptacle outlet, 125 volts. So either 15 or 20 amps is fine. What this means is that you can't take a branch circuit out to this shed in the backyard of somebody's home and just install a porcelain lamp holder, because this leads the owner to buy one of those plastic brown lamp holders with a two-prong outlet, and then force them to rip the ground pin out of an extension cord, and then this leads to a dangerous situation. So if there's electric going to that outbuilding, you will, at the very least, install one receptacle. Then you can put in a switch and the light and all you want, but you will be installing a bona fide, safe, GFCI protected receptacle. 250.32b now, let's take a look at that. This section requires the installer to run a 4-conductor feeder to a second building. You're going out from a dwelling unit out to a garage. They want to run a shirt printing business or something out of the garage in this second building there. Before this code cycle, for a single phase 120/240 volt system, the electrician had the option of running 3 conductors, 2 hots and a neutral, and allow the neutral to do double duty as a grounding conductor. Or he could run 4 conductors, 2 hots, a neutral, and a ground. Now in the 2014, once the 2014 is in effect in your area, it is mandatory to run the 4 conductors for that system. 250.32b. Take a look at 300.21c2. You guys are doing commercial work and installing cable ties, what we would call tie wraps, above a drop ceiling. And above the ceiling is all return air. You know, when you look at the drop ceiling and you see that egg crate section in there, there's no duct work. That means that all the air above that ceiling is plenum rated. It's a plenum rated ceiling is what we would call it. And all the air above the ceiling is returned to the HVAC unit. Well, in that situation there, all the tie wraps that you install there have to be plenum rated tie wraps. And these are going to be a type with low smoke and fume properties. So when there's a fire, you won't be putting noxious fumes in the air and killing people. 310.15 B3C. Tough one here. Emphasis was made that for not only conductors and conduit runs, but also for cable assemblies that the installer would put up on a roof. They are subject to the ambient temperature adjustment if these circuits are exposed to sunlight on that roof. So just a note here that this section and rule was deleted in the 2017. So pay attention to 310.15 B3C, both in the 2014, the 2017, and the 2020. There's changes there. 334.40B. This section emphasizes that the Tycho connectors that you use for non-metallic sheet cable connections without a box are for repair wiring rather than rewiring. Just a point of emphasis there. These connectors are a popular choice when you're replacing just small sections of wiring, like after flood repair work. When I was doing inspections at the New Jersey shore after Hurricane Sandy, there were a ton of these Tycho connectors being used. All right, this is what they look like here. It's a Tycho connector, two pieces. You put the Romex terminated in here on these steps, terminate on this side here, and then you're going to slide the two halves together. And then snap them in together. They're not going to come apart. All right. So Tycho makes these. This is a take a picture of that if you want. It's a Tycho. This is a 2-wire connector, and then they also have 3-wire connectors for your 3-way systems, 3-way lighting, things like that. So they're a little bit pricey. I think I've told you before. If you need one, buy two. If you need two, buy three, because you're gonna mess up the first one, and they're not reusable. So you're gonna mess up the first one, do a little cursing and things like that, get all frustrated, and then you're gonna read the instructions and, oh, is that what they mean? Yeah, that's what you do, man. Read the instructions. So you just messed up one, and now you'll do it the right way on the second one, and then you'll be in good shape. So those are the 334.40B connectors that they're talking about there. They can go together without making a splice inside of a box. Any of you that have done wiring in like the double wide I live in, the building comes in 2 pieces or 4 pieces, and they have a lot of tails that have to be plugged together. Those are the type of connectors I'm talking about here. All right, 406.4 D4. 406.4 D4. This is a very impactful and necessary step in protecting the older circuits in older homes. You know, the older cities like Boston, New York, Philly, Baltimore, New Orleans, Seattle, San Francisco, where there's many of these older homes with the older wiring systems. And many especially still have a 2-wire system. Some of them are knob and tube still, and they only have a hot and a neutral going to the original receptacle. Well, before the 2014 came into effect, it was code compliant to just replace a 2-prong receptacle with a 2-prong receptacle because there was nothing else you could do. But now, if you have to replace a receptacle in a room where arc fault protection is needed today, it must be provided with arc fault protection when you replace it. All right, so that means you're going to have to install like this. Okay, this is an arc fault. Got a test and reset button on it, and it's a chunky type of a device, and you might have trouble fitting that into the box that's there. You may have to put an extension, like a wire mold extension ring on over the original box to get something that's this deep to fit in there. So You only have two choices, basically. Option one is to install the AFCI receptacle, and you got to make it fit, like I said, one way or the other. And then option two, which is highly unlikely, is to provide an AFCI breaker in the main panel. Well, in an older home, it might be a fuse box, it might be a Federal Pacific panel, it might be a Zinsco panel, it might be a fuse panel, a Bulldog, the old Bulldog Pushmatics, okay? But for whatever reason, if you can't get an arc fault breaker, all right, then what you have to do is go to next to the main panel and install an enclosure and just install a circuit breaker enclosure and put a breaker in there, or install a device box and put in a arc fault receptacle type in there. And then you take your wires from the circuit and connect them into this AFCI protection. Now, like I said, that option two is highly unlikely because with shared neutrals and all that AFCI is just not going to stay energized because it does measure imbalance. Uh, it's not as good as a GFCI with its 5 milliamps range, but it will still measure and sense an imbalance. So it's highly unlikely. The easiest thing to do, I'm telling you, you got to go into a house and it's the old wiring, and you got to replace a receptacle and uh, put in the arc fault receptacle type and be done with it. Now, these older homes are exactly the homes we need to protect. So don't play around with this. If you go in, you got to tell them, yeah, I know it's expensive, but that's what's got to go in. This is a very important change here. So we're going to catch up, and someday we'll have all the receptacles in the whole United States changed out. All right, 406.4D5 now, the very next line. Similar to the previous rule, if you replace a receptacle in an area that requires tamper-resistant receptacles today, you must replace the receptacle with a tamper-resistant type. It'll have a TR stamped right on it. And this arc fault receptacle here is tamper-resistant also. You can see the trap doors inside the slots there. So these are already tamper-resistant also. While we're at it, make sure you pay attention to section 406.12, which has expanded the list of buildings and locations that now require tamper-resistant receptacles. 406.4D6. Also, if you replace a receptacle outdoors, it must be the weather-resistant type. It will have a WR stamped right on it. Weather-resistant. It can stand up to the sun's rays and the weather and all that. And lastly, read section 422.5 very carefully. This section requires GFCI protection for many appliances and pieces of equipment that are available to the general public. And they're not related to any special building type. Car vacuum machines, water coolers, tire inflation machines, and vending machines are on the list. All equipment 250 volts or less and 60 amps or less in three-phase or single-phase require GFCI protection. So that would include the 12240 volt single-phase and the 12208 three-phase voltages. Does not apply to the 277 480 voltages. So for example, every vending machine in the United States of America is supposed to be on GFCI protection right now. And it has to be protected by a GFCI device that is readily accessible, don't forget. You got to be able to walk right up to it because we have to do a monthly test and reset. Don't forget. All right, so there you have it. Some of the major NEC code changes in the 2014 NEC. If your company would like a 4-hour or 8-hour code change class to cover all the changes, residential and commercial and special buildings, you can contact me at richvanwert@gmail.com. That's RICHVANWERT@gmail.com. Next session, I will cover some of the major changes in the 2017 NEC. Van Wert out.